much, everybody, for the opportunity to speak with you today. Paul Taubman with 9.connects, and you're here for our presentation, which we have aptly called One Step Beyond. You'll understand that here in a few minutes why we're calling it that. But joining me here today also is Tom Cassidy, who's going to be doing the mechanical aspect of this presentation. So you can see our two ugly mugs up here, or at least my ugly mug. I think Tom's probably a better looking fellow than I am. But nevertheless, what we just wanted to bring to your attention over here is that though both of us are electrical engineers by degree, first and foremost, Tom is very knowledgeable and skillful in the mechanical area of things. And as for me, yes, I do know quite a bit of the electrical stuff, but I'm also very big into the flows. How do the workflows work so that everybody can collaborate with each other? The other thing I wanted to bring to your attention here as well is that we're going to be doing this from two different locations using two different pieces of software. So I'm going to be using SOLIDWORKS PCB. Tom's going to be using SOLIDWORKS, or what we're going to refer to as SOLIDWORKS CAD. And we're also involving 3 machines in this as well. And the intention to show this is to show a real life scenario as opposed to someone just doing this strictly off of a laptop, playing both roles, the electrical and the mechanical engineer, and just showing you the same thing on the same machine. So that's what we've got set up here today for you. Just one quick housekeeping note. If you have any questions, feel free to type those into the chat box there. If you are not muted, please do so, so for the sake of others. And that's all our housekeeping notes are for this point. So let's get into some objectives here. First and foremost, let's talk about the limitation of step files. And so we'll look at the benefits and the limitations of them. Secondly, the path between SOLIDWORKS PCB and SOLIDWORKS CAD. Let's understand that better, because obviously these tools come from 2 different domains and they don't necessarily talk to each other because they're completely different architectures. So how do we handle a seamless handoff between one to the other and vice versa? We'll also look at a very ultra quick understanding of ECAD library structures. And this is really important for mechanical engineers because they don't understand the complexity that we've created upon ourselves here on the electrical side as to how we actually put together a circuit and then place it onto a printed circuit board. And then we'll go through the motions and see all of this good stuff in action. And of course, we'll have some time for questions and answers afterwards. So with that, before we go in, I wanted to make some clarification of definitions. So a lot of times I'm going to refer to something as ECAD MCAD or MCAD ECAD. And what I mean by ECAD is just any tool that is used for mechanical design. And of course, in this situation here, we're primarily talking about SOLIDWORKS. And for the ECAD side, I'm going to be referring to any tool that's used for electrical design. And when we're talking about electrical design, really 99% of the tools out there are based on printed circuit boards. And of course, in this case, we'll be talking about SOLIDWORKS PCB. I also want to make one other clarification as well. SOLIDWORKS PCB is not an add-on to SOLIDWORKS. It is a completely separate tool. So just keep that in mind. And lastly, because everybody has grown up, including myself, even though I was an electrical engineer, when we heard of SOLIDWORKS, we automatically understood that that was a mechanical engineering tool. But as you know, Dassault has been really branching out and getting into other areas of tools. And so as a result, what I don't want to do is just call it SOLIDWORKS. Actually, I'm going to refer to it as SOLIDWORKS CAD to just differentiate it between SOLIDWORKS PCB. So if you hear SOLIDWORKS CAD, I'm still talking about good old-fashioned SOLIDWORKS. It's just for clarification purposes. We're also going to be talking about a real example. So here is a board that we'll be talking about here today. We call it the rangefinder. This is the rangefinder that's fully assembled. The board that we're going to be looking at today is this one right over here. So just to give you a reference of what it looks like. The rest of these boards here are actually what they call COTS items, common off the shelf. So these are things that you can buy off the shelf. We actually designed this particular board here, this rangefinder board, to be a well, we call it a daughter card, but the official term is a shield for this mega board, which happens to be an Arduino board. And these other 2 devices here, this one's the LED display and the sensor over here, again, were just purchased off the shelf. But we just want to give you a reference as to what we've got here. And when it's put all together, it can sense temperature. It can sense up to 2 meters here, so that's what the sensor's over here for. And it can also give you the time and date as well. So that was the whole idea of this little project. We do a lot of other projects too, as a side note. It's just that when we work with other companies, we sign NDAs. They don't let us show the cool stuff that we get to work on here. So this is something that we created so that we could go in deeper into a very specific project without having to worry about those type of things. Let's talk about STEP for a moment. The advantages are that it's a universal language, and the MCAD folks already had figured this out long before we did on the ECAD side of things. And it wasn't until 2008 when a company called Altium said, hey, you know what? We can use step files too, and we can export those out, and we can hand those over to the MCAD folks. And that's really what started that whole industry trend of this collaboration of using step files. So a lot of these tools now, what I'll call Tier 1 tools, including SOLIDWORKS PCB, can take a step file, they can bring it in, and in turn, we can make use of it, and then we can also export it out. And that just allows for a lot better collaboration. And as a matter of fact, I really wish I had had this, because within my own history, when I worked in the defense industry many years ago, I was working with two other individuals. This was a large company, so they had a special group for layout, and they had a very special group for mechanical engineers. And they gave me two very senior individuals, and we worked together on this very complicated little test board that was supposed to fit onto the back of a backplane so we could get some test modules onto it. And what happened is we had to do something that was called a respin. Well, what's a respin? It's a nice way of saying we had to do the board over again, because at that time we did not have this available to us. The layout person actually had to take the dimensions and put it into their tool, and the mechanical engineer put it into their tool. And in the end, some dimensions weren't aligned with each other, and that's what forced us to actually have to do a redo of that particular board, or again, what we call a respin. So having these step files has been really a huge benefit in trying to collaborate between the electrical world and the mechanical world. Right, there we go. So let's talk about the disadvantages of these step files. Well, first and foremost, it's a major hassle dealing with the importing and the exporting of these. And where do you make them available? Because yes, in some cases you can put them in an email, but more often than not, most emails are really limited to maybe 15, possibly 20 megs. And those step files, as you probably know, get really, really large. So where else can you put them? Well, obviously you can put them in a shared drive. You can put them possibly into an FTP site. Maybe you have some other completely different way of handling it, maybe through Dropbox, for example. But the point is they're really large, and then you've got to communicate that, and then someone's got to go basically put that there, and somebody's got to retrieve it. So there's a lot of administrative work that has to go behind this whole idea. In SOLIDWORKS CAD, for example, the PCB comes in as a bunch of assemblies. And we're going to show you that here in just a moment, but just to give these points out. So if you're familiar with this, if you take in a step file, you probably know that if you get it with a board with a bunch of components on it, as a step file, it doesn't define what's the components, it doesn't define what the board is, it doesn't define what the whole is. It's just a bunch of things that just kind of come in, and you've got to discern which ones are which. And it takes a lot of work. And of course, if a new one comes in, then you've got to go through that whole process all over again. On the electrical side, if we get a board with components on, it really kind of comes in as one big blob. Nothing of it can really be salvaged. So at that point, all we can ever do is use it for maybe a fitment check, but we can't extract off a component. We can't extract off a board off of something that just has everything attached to it. And we'll demonstrate that here in just a moment. And there's no intelligence behind it. So it's really for aesthetic purposes only. So if I send you a board that's got all these components on it, I can't make a bill of materials. I don't know who the manufacturer is. I don't know their manufacturer's part number. I don't know any of that information. All I see is just a pretty board with a lot of components on it. So what I'm going to do here is I'm going to jump out of this for just a moment. I'm going to show you our screens here so we can demonstrate some of these issues that we see with the step files. So I'm going to bring up Tom's screen over here. I'm going to enlarge it, and I'll let Tom talk here for just a few moments in regards to this step that he's brought in.
Okay, hello everyone. As Paul's mentioned, this is a step file that was generated by Altium. Basically, within Altium, you can define step models for each individual component. Once it's placed on the board, Altium can generate an overall step model of the entire assembly. So as you can see, it's actually pretty realistic. We did a pretty good job on the models. We created some actual models, and we downloaded some models from manufacturers. But unfortunately, as Paul was saying, this doesn't really do much for us in terms of what these things actually are. You can see there's basically a list of step models over here, and we can select each one, but we can't really move it. We can't open it very easily. It basically just doesn't do much for us other than give us an overall, pretty picture of what the board is going to be. We do have holes, so if we wanted to do a fitment check, we could do something like that, but there's no way I, as a mechanical engineer, could say, no, I need this moved or whatever. So it really it doesn't do a lot for us other than give us a good picture.
And what I'll do is I'll show you on my side over here. So what I'm going to show you is SOLIDWORKS PCB. So let me bring that here onto the screen here, and I'll zoom it in. So we are in SOLIDWORKS PCB, which is also very capable of adding in step files and pushing this information over to SOLIDWORKS CAD. And so what we've got over here is we've got the real board down below, and we have the step one above here. So here, as I mentioned before, this is the board itself. So yeah, it looks the exact same, but the difference is that I can take parts in the real board and move those around, as opposed to this here, which is just simply a blob of a representation. As a matter of fact, if we go to the 2D view, and this is the view that we tend to work in about 95% of the time in a layout tool, you can see it's just a box here, just representing is what they call a 3D body, as opposed to what you see over here where we actually have components, and we've got our layout, our copper pour, our traces, and all the other primitives that are associated with this particular board over here. So that is what we're dealing with when we're dealing with step files. Now, yes, I can move these things. If, for example, if I go to the 3D mode here and I click on this, I should be able to move it. If I can't here, I'll just do it on the 2D mode. But I can take this. It may be locked. Yeah, we locked. That's okay. But the point I'm trying to make is I can move these things here as opposed to on a step where I just have no opportunity to do so whatsoever. So I won't get into the minutiae of the locking and the unlocking and all the other features that go into this. But as we go along, you'll see I'll be able to move these parts quite easily. All right, so with that being said, let's bring back the presentation. So we'll go back here. All right. So how is this new method of communicating work? Is there something better than steps where just kind of taking these files, pushing them out, and then having to pull them in through some type of import mechanism? And the answer is yes. There's what's called a collaboration, and we can have these two tools talk to each other in near real time. And when I mean near real time, I'm talking within minutes, if not seconds, of each other. And obviously, it depends on the size of the board. It also depends on the latencies that may be going on in the network over here. So what we have set up over here, as you just saw, we have SOLIDWORKS PCB. Now, Tom did make some mention of Altium here. So SOLIDWORKS PCB was developed by Altium. This SOLIDWORKS PCB is a specific product that was developed by Altium for SOLIDWORKS. And it was developed so to make this flow as easy and as seamless as possible as well. If you happen to have Altium Designer, if your electrical engineers are using that, there is another product that we can talk to you about that will allow Altium to do the exact same thing that you're about to see over here. Nevertheless, here's ECAD, here's the MCAD tools, and how do they talk to each other? Because they're completely different architectures. So, for example, in SOLIDWORKS PCB, almost everything that we do is going to be grid-based. And we are very heavily reliant on these things called primitives. So we have a primitive for a via, we have a primitive for copper, we have a primitive for a polygon pour. Even of all of our components, which is considered primitive all itself, they're made of different primitives as well. So they're very, very specifically defined. We cannot create new primitives, and we can't even change the properties. Like when I say change them, I'm talking about add a new property or remove a property from any of those primitives as well. So we've got to work within that primitive set. Whereas in SOLIDWORKS, everything is pretty much a part, right? You either have a part or you have an assembly. And so as a result of that, because it just recognizes it as a part, there has to be some intelligence that explains, hey, these things that we're calling certain primitives on the electrical side need to be also understood on the mechanical side as well. So that's why these things really just can't talk to each other directly. So how do we handle that? Well, there's a feature that's called the SOLIDWORKS PCB services. So this is actually a server, and it's not of any extra charge. As a matter of fact, if you purchase SOLIDWORKS PCB, it automatically comes with this. But it has to be visible to all of the software that's going to communicate back and forth with each other so that this thing can act as basically an interface between SOLIDWORKS PCB and SOLIDWORKS CAD. And that's how this will work, and you'll see this here in just a moment. Now, you'll notice a little comment down here at the bottom that ECAD owns the project. And it's not because we have an ego or anything. In fact, it's because of the flow that we have to deal with on the electrical side, and you're going to see that here in just a moment. But by having this flow set up, now what you can do is you can involve the mechanical folks so that they can generate or modify a board. They, more importantly, can help move components around so that it benefits both the mechanical side and the electrical side, and you can also add and move holes together. So that's the whole idea over here, is that yes, we may have to keep this as the quote-unquote start or the owner of the project, but stuff can be passed back and forth to each other so that there is an ongoing collaboration. No more of this, hey, mechanical folks will give me the board, I do all my things over here, and then I throw something over the fence to the mechanical, and then they got to somehow make it work. You don't have to do that anymore. All right, so what is the flow? Why is the ECAD one so complicated? Well, let's first and foremost look at the MCAD flow, which I'm very jealous of because it's so linear. When you start something in the mechanical design, you start off with a part. And when you create that part, you're able to reuse it. So in essence, you're not only creating a part, you're also creating a library for that part. And you can reuse it over and over again. And then eventually you put together these things called an assembly where you have a bunch of different parts. And maybe you duplicate that part over and over again. Maybe you use different libraries to put it together. However you do it, it's all done within the same editor. In very linear in fashion. It's really it's beautiful, for the lack of a better term for it. Whereas on the ECAD side of things, we have it a little more complex. So when we start a design, we start it in something called a schematic capture. And the reason we have to start it there is we have to have a conceptual concept of how we're going to put this together. And when we're dealing with the schematic, there's a couple things you got to recognize. First and foremost, it's dimensionless. We are not dealing with anything that's of a dimensional nature in the schematic capture. It's conceptual, and more importantly, it's symbolic. So what that means is that everything that we use has a symbol to it. And there's well over 100 different symbols that are recognized by an organization called the IEEE. Here's just one example of them that you see here. So this here is all the same thing. You see that this is what's called a variable resistor. So this is the symbolic representation of a variable resistor. And what we mean by that is just a resistor where you can change its resistance. Here's its physical representation on the printed circuit board, and here's its 3D representation. And we pretty much need all three of these. But in the schematic capture, I just simply need the symbolic representation. Once we put all this stuff together, we need to push this information over to something called the PCB layout. So what are we pushing over? Well, generally pushing over what's called a net list. And that net list says, hey, this is how you're going to connect from one component to the next. So if you've ever seen this thing, and we'll show it today, it's called a rat's nest. That rat's nest is based off of the connectivity that was developed in the schematic capture. So in the PCB layout, we can't use the symbol library. We actually have to create another library, and that's called the footprint library. And in SOLIDWORKS PCB in particular, we show both the 2D representation. So this is where it's supposed to sit on the board. It's copper representation. And we can also do its 3D representation. And this capability right here is what allows us to eventually communicate with SOLIDWORKS CAD. That's the cool part about this here. In one sense, I'm just going to throw this out at you, what you're seeing over here is a really, really great example of electromechanical design. Because when you are putting the layout together, you're dealing with not only the electrical aspects of this design, you're dealing with the mechanical aspects of it too. So a lot of layout people, though they don't realize it, really are electromechanical engineers. So how does the flow look? In short, you design something in the schematic, that information gets pushed over to the layout side. 95% of the time, as I mentioned before, we actually work in the 2D. So we would place these parts out. And then from there, once the placement looks good, then we start doing the routing between these components here. And yes, we can see the 3D to make sure that there's some fitment, that we're not going to have some issues with components that are going to be on top of each other or too close to each other. So we can do those type of things. But now, because of this 3D capability, we can also include the MCAD, and we can push the stuff back and forth to each other. And that's exactly what we're going to show you here right now. So I'm going to escape out of our PowerPoint presentation, and I'm going to jump back over here to our design. The one thing I'm going to do is going to remove this step file over here. So what do we have here? I'm in SOLIDWORKS PCB. Okay. And what I have here is a completed board. And what I want to do with this board is I actually want to push it over to the mechanical side so that, that Tom here can make some modifications to it. And we can see how seamless it is to push the stuff to and from. So here's my board over here. I'm going to hit the 2 keys so I can get back into the 2D mode. And because the SOLIDWORKS PCB is connected to the server, I have this panel over here that allows me to push and pull as we're going along. So in this case, I'm going to push this design over here. So I'll just call this webinar. So every time we type something in over here on this screen, this information will also get passed along over to the other side as well. So whatever I type, Tom is going to see. So you got to be careful what you say. So if you're not happy with your mechanical engineer, the mechanical engineer is not happy with the electrical guy, Be careful because there's no way to delete these comments here, so once they're put, they're put. But a lot of times it's good to put information as to what got changed here. And once it does get pushed over to the mechanical side, you will see those changes as well. So there's no guessing that goes on as to what got changed. So I'm going to post this here. So this is now communicating with that thing called the PCB services, and it's pushing the design over to there at this point in time. Now it's complete, and now I'm going to minimize my screen here, and I'm going to bring up Tom here.
Actually, Paul, Skype hung up on me, so I have to call back in again.
Okay, very good. Go ahead and do so, and I'll pull it back here. Answer. And I'll mute here. There we go. So there's Tom. And there's Tom's screen. I'm going to widen it out over here. So Tom is now going to show us what happens here on the mechanical side.
Okay, so in a similar manner to how SOLIDWORKS PCB had a communications tab, there's an add-in on SOLIDWORKS called SOLIDWORKS PCB add-in that lets me communicate with the server as well. And when nothing is open, I basically have two options. The option I'm going to do right now, since I know Paul created a project, is I'm going to pull a board from the PCB services. So when I press that button, it connects to the server and it says, these are your choices. And there's only showing one, but we could essentially have a fair number of choices. So this is the project that Paul created. So I'm going to say, yes, let me connect to that. It's now going to ask me to where I want to save stuff locally. And once I do that, it is now communicating with the server, and it is pulling all the information that Paul posted, but it's pulling it from the mechanical point of view, not an electrical point of view. That's the really nice thing about this. It's got to think about it a bit, but you see as it's coming up, you'll see I actually now have a mechanical representation of the board, the project that Paul posted. So here's my project. And as you can see up here in this, I also now have a message screen, and I can see the message that Paul typed in. Basically says webinar. And as he mentioned, we have stuff that we had from when we were getting set up. So as you can see, this is very similar to the step model, except that these are actually parts now. So I can actually do things with these. If I want to measure things, I can move things around. I can suggest changes back and forth. So like down here is a switch. I can say, no, I want this switch up here for mechanical reasons. And I could say, okay, these chips look good, but maybe I want to move something else. I'll just do the one for now. And so you can see I couldn't do that in the step, but here in the SOLIDWORKS, I can actually do that. One little aspect I need to point out, though, is kind of interesting. You can see on this my board here that I can actually see copper traces and I can see text. This is called overlays. These will be the silk screens on the board. These are actually part of the circuit board itself, not the part. In the electrical world, the footprint and the text would go with the part. But once I get into the mechanical world, in order to fit this paradigm, we basically have to make that stuff part of the PCB itself. So here you can see this is the PCB part, but it's actually got a lot of stuff in it that's not just PCB. So that's just one interesting aspect of what we're doing. So anyway, to get back to the collaboration, you can see I decided to move this switch over here. So I'm going to tell Paul that. So I'm going to go back up here, and just like he had the pull and the push, I now do as well. So I'm going to push this design. I'm going to say I moved the reset switch. And then Paul, if you want to go split screen, we can see how that reacts on your end as well when I post it.
Sure, I'm doing that right now.
Okay, so if you see on my, if you see on my side, I'm going to hit the post button, and then we should see it go up to the server, and then Paul should get a message saying I've posted something.
There it is, and you can see that now it's been detected. So one of the things nice about both the tools is that it is pinging the services every so often to see if an update has been made to it, and it will indicate that. So you don't have to keep on doing a self-ping on or sending an email to the other person saying, hey, did you send this? Did you send this? It will just show up if you have the project open and the panel is available there. There's one other thing I just wanted to note too, because this question might come up with some of you here on the mechanical side of it. So what you're looking at when it comes to the copper is what they call a decal. And this is a really ingenious way that that SOLIDWORKS kind of came up to deal with the primitives of the copper itself. And because if you look at this, all of these things are individual primitives, and to bring all of these in would actually take quite a bit of time, and a couple more minutes than what we just saw here. So if you don't need to necessarily have that level of detail, by default it's going to come into as what they call a decal over here. So it's almost like a sticker that they put on top. Now once I push some stuff back over here, that decal will update. So it's not going to be permanently incorrect here. It's just once I make a change here and push it back, it will correct itself. If you do require the copper, there is a way to turn that on. So if you're doing like thermal simulation, and that's something important to you, you can definitely turn that on. But for our purposes here, just having the decal just gives a better understanding of where the traces are. We also have a copper pour on top of this, so just keep that in mind as well. So I'm gonna take a look at what he did here now. So you remember he had the SW5 switch got moved here. Now, if I had a board that had 1,000 parts on it, I probably wouldn't know that. So he did indicate that he had some changes, so I want to view the changes here. So I'm going to click on that, and let's see what it brings in. So it brings in actually two things. So one of the things it does also bring is to sync in the locks. So one of the new features in SOLIDWORKS 2019 with this whole collaboration is that both the electrical and the mechanical engineers are able to lock down components. And that's really important if you're trying to pass stuff back and forth during your placement here. So what I'm most interested in though is this switch. So I'm going to click on this because I want to see where it is. And what you see is kind of the ghost of that switch moving here. So if I was zoomed out, I'll still see it again. So it's just a matter of just clicking on it and seeing it. If it's kind of difficult to see because of the colors that were selected for the 2D here, I can always go into 3D. And in the 3D, I can again click on it and I can see it move this way as well. So it allows you to see what you want there. I can accept or not accept it. In this case, I will accept it, and I will press accept at this point in time. So even if I didn't want to accept it, I'd still hit the accept button. So I'll hit this here. And now the reason this is coming up here is that it's going to ask me to repour the board. I'll say repour it, and that's fine. So you can see that change here once we do this. Now, of course, keep in mind, the way we have this set up over here, if I hit the 2 key, it did get moved, and it's now been locked in and recorded here. It's just that my routes would have to be moved at this point in time, and there'd probably be some issues with some shorts. But for our demonstration purposes, this will work just fine. One of the things we mentioned earlier on is that everything has to start or end at least on the ECAD side of things. So the ECAD is the quote-unquote master of this. So regardless of whether I accepted this or not, I still have to push this back over to resync up with the mechanical side. So I'm going to push this over here, and I'm going to say accepted. All right. Well, in fact, let's put a little more there. Accepted SW5 switch move, and then I'll post this again. So hopefully you're seeing that it's pretty easy to just make these changes, post them, and then push them over to the services. So once I've done that here, you'll see that on Tom's screen. I'll move that over so you can see it. He now has the notification up, so we'll widen his screen here again.
Okay, so as Paul said, he made a change, which is really just accepting what I had suggested. I can do the same thing on my side. I can say view the changes, and since there's really not much of a change other than the copper, I'm not going to see anything move because he didn't move any parts. So really all he's doing is changing the copper. So if you want to look over here, you can see I've got the footprint still on this decal. When I accept the changes, that should move, and I should now see the footprint going up to where the new part is located. And once it gets done thinking about it, we should see that. And here you can see, yes, that's what happens. So now the footprint for the part got moved up, but obviously Paul didn't change the traces, so they're still where they used to be. And then you can see on the messaging, I can see what Paul had said about that. So at this point, I am synchronized. My board is the same as what Paul is using. And we can, you know, if I'm not going to make any more changes, where everybody's happy and Paul can go on with his work and vice versa.
So what we're going to show now is we're going to show another example. So in one sense, this example that you see over here is really a tough case. And the reason why this would be kind of a tough case for collaboration is because the routing has already been done. And one of the things that we would always encourage people to do with these collaboration tools is to get the placement moving before you ever do the routing. So in this case here, yes, we would have to do some correction to the routing. Keep in mind this as well. This is a rather simple board that we put together, but even something that has, let's say, 100 pins to it, and it has to get moved over even 1/8 of an inch, can literally take up to a week to 2 weeks to reroute. So this is why the emplacement is so critical to actually do from the very beginning, rather than to try to do something like right now where the routing has already been completed. So what we also want to show you here is that we showed you initially this being initiated from the electrical side, but it can be initiated through the mechanical side as well, and that's what Tom's going to demonstrate here.
Okay, so I'm back to the start of the design, and originally there were two choices. I could pull a board from the PCB, one that's already existing, or in this case, since I'm going to be initiating the project, I can create a new board assembly. So I'll do that here. It's going to ask me for the name, so I'm going to say this is going to be an MCAD to ECAD project. It's for the webinar. So what I'm going to be doing here is creating a new project on the server. So it's very important to recognize that that's the purpose behind this. I'm creating something on the server that Paul can then connect to and use. So once I do that, it's going to set everything up, and once again ask me where I want to save my locals. I'll just do it here. And one thing we kind of glossed over is, in order to communicate the properties, electrical properties to mechanical, the board itself has to have a few extra properties that aren't typical of a SOLIDWORKS part. If we go over here, you can see that there's actually a couple of properties: top board face and bottom board face. This is needed on the electrical side to know where a component can be placed, and there's actually an option to be able to swap a component from the top to the bottom and vice versa. But in order to do that, we need some extra information that's not normally present in the mechanical world. So to help solve that problem, SOLIDWORKS will now create a blank board for me with all that included. And in fact, I can show you there's a few other properties embedded in here. There's some GUIDs and names and stuff that is needed in order to synchronize things. So basically, it creates a blank board. I can then go in and change this as needed, and this is all purely, this is mechanical. So I can open the board. I can edit. I guess I can edit the sketch. I can say I actually want to make this board a little thinner, a little longer. And let's just, for the fun of it, put a couple of holes in here. Some weird mounting holes. So obviously, if I had already had a more typical case would be, I would have already done the design for an enclosure or a case, and I need a very specific outline. I can go ahead and modify this board to fit that outline. I can put it in my SOLIDWORKS assembly, make sure everything works. Basically do what I need to do on this guy to see if I can real quick change the color, make it look like a circuit board. Okay, so now we've got our typical green solder mask overlay. So now that I've got what I would like to have Paul use as the starting board, I will push this up to the project. So actually I need to go to the actual assembly that I'm working on, not the board. Okay. So now I can go back to the SOLIDWORKS PCB add-in. You see now I've changed to my standard push and pull buttons. So my first thing is push, and I'm going to say this is the initial design. And I'm going to post this to the server, and it should now upload it. And the server now has a copy of this. So now Paul has to go and do a little bit more work on his end to actually create a PCB project on his side that he can use this in.
Right. Okay, so I'm gonna minimize the screen over here and bring in SOLIDWORKS PCB. So keep in mind here, I'm not going to get a notification that this project has been created because this is a completely different project. However, now that he's already created that, I can definitely go in and see what he has created in the services. So I am actually going to go into File, Open Project, And so I'm going to see the same thing that he saw on his end. And now I'm going to see that this has been created, and I'm going to press OK at this time. So I'm going to bring in this project. Now in SOLIDWORKS Electrical, we don't have the, as I said, we've got different editors. That's probably the best way to look at it. We have different editors that do different things. So in order for me to see this over here, I have to look at it from the PCB layout editor. So I'm going to go here and I'm going to add new to project, and I'm going to call it PCB. And you can see that I get the same size board that he got initially over here. But the cool part is he's already given me that board. So I'm going to do a save on this project. It's also going to ask me or prompt me for that save too, and I'll say save for now. All right, so what do I need to do? Simply need to go over here to the collaboration. It already recognizes that Tom pushed something in. So now that I've got this project down, it says, hey, you got an update already. So I'll view the changes. And you can see that it's got the board outline and all the cutouts. So I'm going to right click and accept all of those. So let's do check all, and let's press accept. And now I've got the exact same board that Tom just made here a moment ago. And if I hit the 3 key, there it is. I can see in the 3D design. So what about the other project? What can I do? A couple of other things too. So one of the flexibilities that we do have in a project of this nature is if I had actually already started my project, it's not that hard for me to take my files and push them over into this now managed project that you see here. So what I'm going to do here, as a matter of fact, I'm going to walk through this only because I want to show you the different type of files we got to deal with. Here are my 2 schematic files. Here's my library file. Here's my schematic file. As we talked about earlier, we just have to deal with that. That's what we do here on the electrical side. I'm going to copy these into this new project that just got created, and I'm going to put those in there. However, I've also got to tell this thing called the PRJ PCB that these are associated with it. So I'll do add existing to it. Let me just grab this directory here. I wish we could do a Julia Childs on this where we could just show it instantly shows up, but it doesn't work that way. So bear with me as we pull these things together. But hopefully you see what's going on here. We just have to get those things synced up. So I'm going to bring in my 2 schematics and then again my libraries, and I'll press open here. And those are now associated to this project. The last thing we really wanted to show you over here is this process of actually pushing stuff from the schematic into the PCB and then from the PCB into the mechanical, because hopefully you'll see that that's where the value add is here. That if we can push these parts over to the mechanical side and the mechanical will help us with the placement, it'll make everybody's jobs a little bit easier. So I'm going to go into one of the schematics here. And by the way, there can be literally dozens of schematic sheets. This is only a 2-page schematic here. But what I'm going to do now is I'm going to take this information, I'm going to push it over to the PCB side. And this is a normal process that everybody goes through during the layouts. They make their schematics, they go through a review, they say, all right, let's get this pushed on over. And they usually don't want to do this piecemeal because of the net list that's associated with this. So I'm going to tell it, hey, take this information, push it over. So it's going to tell it where to find its footprints. And these are the connectivity points that need to be associated. So I'm going to press execute changes. This is all going to get pushed. And now we've got a pile of parts with these little points here. So those are what's called the rat's nest. So that's what guides us so that we know how to put our copper traces from one point to another over here. So what can I do with this now? Well, the cool part is that yes, I could take these, and of course, for the purposes of this demonstration, I could, I'm just going to kind of put them around here. But what's neat is they don't all have to be on the board. So if I want to give these over to the mechanical engineer, say, hey, look, take the parts that you need and put them strategically where you need to do so, he can certainly do that. So at this point in time, I can take this jumble of parts and just push them back over to Tom here. So I'll just say that the initial component placement, placement.
Do you want to go split screen?
What's that? Yeah.
Do you split screen?
Yeah, so I'll push this over here so you can see what's going to happen on Tom's. Let me just smack this up here so we make them equal. There we go. And then I'm going to press post. So this pile of parts is now going to get pushed into the services, and then Tom will be able to take it from there.
This will take a little bit of time since there's a fair number of parts to be pushed. It's uploading all those step models. But as you see now on my side, I now have a message saying, hey, something has changed, take a look.
So we'll make you the presenter here.
So I'm going to do as Paul did. I'm going to view the changes, and it's going to show me a lot of stuff. All the parts got added, component added, some shapes changed. I mean, a variety of things happened. So I'm going to do the same thing. I'm going to say check them all and accept, and sit here a bit while all those parts now get downloaded to me. It should be a little quicker since the machines are next to each other right here, but you can see it's basically building up the circuit board on my side based on what Paul has done.
So, and by the way, as a side note, usually the initial push that you go from one to the other, this probably takes the longest, but the subsequent pushes will be a lot faster because those parts are already defined. But there you go.
So now I can see the original pile of parts, as Paul said. So if I want to, I can say, no, I want to have this guy here. I want to have this guy over here. Apparently I'm violating some outline. Okay. We're just kind of doing this real quick. And let me just do one other thing. I think if I right click on a part, there's a PCB add-in feature now, which lets me flip the PCB component. And this gets back to that special information I mentioned earlier with the top and the bottom side. This is not what you would normally see on the SOLIDWORKS side. But I can basically, now I want that component on the back of the board. I don't have room on the top. So you can basically see now it's mated to the bottom of the board, which is what it would normally be in the electrical side. So I'm going to say I need that on the back. I want those connectors where they are. I don't really care where these other parts are yet. Actually, let me bring a few more connectors in just to make it more realistic. So anyway, so as you can see, I can adjust this as needed from the mechanical side. If this was an enclosure, I could do fitment checks. I could modify my enclosure to fit the new parts, whatever I need to do. Once I'm happy with the placement, I can then go push it back and say, parts have been moved. Paul, do you want to split screen to see that again?
Yep. Do that here.
Okay, so I'm now going to go ahead and post this. It's going to think about it, and Paul should get a message. There we go.
And there you go. So you can see the message at this time. I can view the changes. And as we showed before, not only does it show it, if I want to see where they got moved to, you can see it getting moved to the other side. In this case, moved to the bottom of the board, that P1, or if it's just going to float to one side or the other, depending on where I located it. And at that point, I can accept them. Some of them I can accept, and some of them I don't have to accept. So I can do that here. Press the accept changes, and then push it back over at that point in time. So hopefully you're getting the idea that that's what this can do. It really can push the stuff to and from between the electrical and the mechanical sides of the tools here almost pretty much seamlessly, right? And that's what you were able to see here today.
Okay, Paul, you might want to mention too, I'm sorry, mention that on the mechanical side, I don't know anything about clearances in electrical. So depending on how the footprints are, I could potentially move a part that fits in the mechanical world but doesn't fit in the electrical world. And so it's very important to make sure you go back and forth and make sure everything fits. So even though I've moved something on the mechanical side, I can't assume that that's going to work.
Yep, very true. And we do, and not to get too deep into the tool over here, but there's what's called the design rules, and those get set up to make sure that we keep certain clearances, primarily to make sure we don't short anything, but also just for mechanical, actually manufacturing purposes as well. We can't make things down to the micron level just yet. So we have to be very realistic about what we do to ensure that it can be manufactured. So that's what we've got. Thank you, everybody. Have a wonderful day. Thank you.